So I'm Shariff. So I'll be presenting our work on on an elicitation study that we conducted for what we call hand proximate user interfaces. So so first of all, I just want to give a brief overview of what mixed reality applications are. So mixed reality is basically overlaying digital information on top of our everyday life. So when we are using a smartphone, what we do is we usually go into we have to look at its screen, right? So the idea of mixed reality is that when we are going about doing our everyday activities, overlaying digital information on top of that itself. Now, this is already being used in several domains, for example, in industrial manufacturing, in medicine, and systems like the HoloLens 2 is a very good example of this. And so one thing of mixed reality is it has the potential to be the next evolution of smartphones, right? One of the limitations with mixed reality applications that we have right now is it's primarily media interaction based. That is, we have a screen that is basically floating in front of you, and you are basically interacting with media. So for an everyday computational platform like a smartphone, going around waving your hands in the public might be a little awkward. And on the other hand, having media interactions also can be fatiguing. As a solution to this, what we are proposing is we already are familiar with the interaction of smartphones, and we're already comfortable with it, and it's also socially accepted. And what if we replace the physical mobile phone with a virtual interface? And that is what we mean by a hand proximate user interface. So this would be leveraging the advantages we have with the smartphone. That is, it's more comfortable, we are familiar with it, it's socially accepted, with the more expressive and more interactive space that is made available through mixed reality application. So as an initial foray into this area, we were looking into how we can lay out these interfaces, how we can arrange these interfaces, and how do we interact with this. So there has been quite a lot of work that has been done on media interactions and how to optimize them, and there have been varying different approaches that has been taken to this, from optimizing the selection using pointers and how to give visual feedbacks and etc. And there's another body of work as opposed to interacting with the media elements, having indirect input. Now, of course, there are interfaces such as pointers, and we are particularly interested in hand-based interface. Recently, people also have looked into using the hand as an input device as opposed to just an gestural input device, as in having it as a functional input device. Several studies have actually looked at which parts of the hands are actually comfortable to interact with. So among the literature on hand interfaces, we are particularly interested in the work related to micro gestures, that is, gestures that are just related to the hand itself. So another body of work that is very close to what we are proposing here is the body-based projections, such as the OmniTouch or the Sixth Sense. So what they basically have is a body-mounted projector which projects whatever information they want to show on a surface in front of the user. It could be the hand, the skin, or one of the surfaces they have around. So the difference between this and what we are proposing is like in mixed reality, we don't need an actual surface to project information on. It can be a virtual element that is basically floating in the air. And also recently, in a particular survey on smart glasses, the authors identified 8 interaction goals for smart glasses. So, and they note that none of the previous work actually tries to address all 8 of them. And out of these 8 interaction goals, we identified 6 of these interaction goals to relate to applications that we would generally see on smartphones. And so what we also noted is to the best of our knowledge, none of the previous work have actually tried to address all 6 of these interaction goals either. And the proposal that we are putting forward, the hand proximate user interfaces that we are describing here, we believe would address all 6 of these interaction goals. So what we wanted to do as an initial foray into this interaction space, so we wanted to look at how we would display information on and around the hand and how will we interact with it. these elements that we display. So we conducted 2 studies. In the first study, we looked at how information the display the elements to interact with, or the display elements would be laid out. In the second study, we looked at how people would like to interact with these elements. So as an initial step, we are only looking at one-handed interactions. We're not looking at any text input, and we are focusing on smartphone applications. So for the first study, we asked participants how they would design the user interface for hand proximate user interfaces for 5 applications. So they basically described how they would lay out the elements for a particular application on and around the hand. So we recruited 12 participants with their background in user interface design. And in order to label the data and analyze the data, we identified 3 dimensions. The first one was the layout position, that is relative to your hand. Where is the elements that is being laid out relative to the hand, where it is. And the second one was are they holding the hand horizontally or vertical? And the third one, if they have multiple elements, say for example, like in the home screen, how will they arrange those elements on the interface? So these were the layouts that we derived based on these descriptions. So these two were the more dominant layouts that were proposed. That is basically having the interface on top of the hand itself, and then having the interface. And some participants preferred having a clear hand, being able to see their whole hand, and have the interface displayed above the hand. And also, some participants emphasized on which part of the hand they like to have elements displayed on. Some participants preferred using the palm for certain applications. Say, for example, for the video player, having it on the fingers might be, given the fact that we'd be moving our fingers a lot, having the display on the fingers itself might be too distracting, and so they prefer the palm. And also, some participants preferred having the interface on the finger area because they felt that it's easier to interact with the interface if it is on the fingers. And some participants actually preferred laying out the interface such that it is on the skin itself. And also another layout that we saw is people preferred not just using the hand, but they also like to use the larger space around the hand as well. And some participants also noted that having the hand holding the hand vertically resembles the smartphone, so they preferred that. And with regards to arranging elements for a particular interface, there were 3 different layouts. The grid layout, the horizontal list layout, and the vertical list layout. So based on these layouts, for the second study, we used the on-hand and the off-hand as 2 different cases for comparison. And for the home screen applications, we selected the grid layout. And for the multitask screen, we selected the horizontal list layout. And for the second study, what we did is we did a user elicitation study. We did a user elicitation study. So, and for this, what we did is we generated 2 videos with the applications and the given cases, as you can see here in the slide. And we asked the users to describe, watch the videos and describe how they would imagine interacting with these applications for these 2 different scenarios. Now, the user elicitation studies have been shown in previous work to generate interactions or gestures that are more user-friendly than gestures and interactions that are proposed by experts. And to analyze the data, again, here we identified 3 dimensions. The first dimension relates to how exactly they were using the hand. Are they using only just a single finger, or are they using multiple fingers, or are they using their entire hand? Flow relates to if a particular action is continuous or discrete. Are you tapping, or are you just swiping to increase the volume, for example, which is a continuous action? And the binding relates to are they interacting with an element, for example, if they're interacting with a button, or are they interacting with, or are they just performing a gesture which doesn't actually relate to a particular element? So, the gestures that were generated were very similar to that what we would see on smartphones, tapping and swiping. In addition to that, participants also proposed more hand gestures like flicking, flicking the hand or making a fist, for example, to go to the home screen, for example. And we also calculated what we call the agreement rate for elicitation studies, which was proposed by Watau and Brock in 2015. You can say like the lowest agreement score was for the fast forward and rewind task for the media player. So the main reason and we believe the main reason for this low agreement rate is probably because of the way we had presented the task to them. So the idea of fast forward and rewind might be somewhat different in what we see in smartphones today. So different participants took it differently. Some actually thought of a slider that we see on like media players we have today, and some actually were thinking of buttons to like press and hold to go back and go front. And with regards to the biggest differences between the on-hand and the off-hand cases were with the zooming activity for the map application and selecting elements on a browser. Well, for the zooming task, for the on-hand application, participants actually were thinking of directly interacting with the map that is being displayed on top of the hand, as opposed to having a pinchment, which was more dominant on the off-hand case. And that is basically people were not actually looking at, hey, we have we're not directly thinking about making use of tactile feedback, as opposed to they were trying to interact with the visual element or looking for visual feedback, I guess. And with regards to selecting when the interface is on the hand, they would do the same that they would do what they would do on a smartphone. And when it is offhand, they used different techniques. For example, like in pre-smartphone, before we had touch screens, we would actually go through the links and then select. So some participants actually proposed that. So the difference for selecting elements on a browser comes from that. And with regards to other than that, most of the tasks had very similar agreement rates for both the on-hand and the off-hand, which we found interesting. And most of the tasks that had high agreement score, actually the gestures that were proposed were very similar to what they would do on a smartphone. And there is like a common consensus among participants, and I guess like in general populace, as to do certain things. So for example, if you're playing a video, you tap, right? So so the ones that had high agreement scores were very similar to that what we see on a smartphone. And the task that had medium or lower agreement score there wasn't a clear consensus, I guess, among participants. Like for example, the rotating, which was an interesting sample. So some participants actually emphasized that, hey, if we are using the smartphone with just one hand, it is practically impossible for us to do this with just one hand. And yet they were able to come up with gestures for that. And also again, like I described with the fast forward previously, and for other tasks, people took two approaches. One, they would use a gesture like swipe left or swipe right, or they would prefer to have a button on the screen and then tap that. So in addition to that, we also asked the participants how cool, convenient, or comfortable they found either the on-hand and the off-hand cases were, and to compare the different cases that we had. And what we found was that there wasn't much difference in terms of these factors between the two cases. We also asked participants how likely they would use this in future, or the two cases in the future. Again, participants seem to prefer both in a similar way. And when we tested for which of the three factors, coolness, convenience, and comfort, would predict the future use, we found that the convenience was the factor that predicted future use the most. Also, we asked participants how likely they would use the gestures they had proposed in public, while most of the participants said that they actually would use the same gestures. Two participants for specifically two gestures. That is when they were when using a hand gesture, for example, when they proposed using a fist to go to to perform a certain task. They said that they would not use that. Rather, they would have a button and interact with that button, then use a full hand gesture. So just packaging the entire presentation into one slide. So so we are looking to expand the interact. So we can look at this in two ways, I guess. One, we can think of it as expanding the interaction space of smartphones, and also bringing the smartphones interaction space into mixed reality. And using the thumb seems to be the most popular way of interacting in this space, even though there are other approaches. For example, none of the participants actually looked at using other finger flexations. For example, expanding your fingers is one thing that we internally talked about, but none of the participants came up with that. And another interesting thing is the distinction between tactile feedback and visual feedback. Some of the participants, as I described earlier, prefer to were looking for visual feedback as opposed to thinking about tactile feedback. So in future studies, in future implementations, we'd like to see how these two actually differ. Is how important is it to have tactile feedback when we are actually having a virtual interface display on hand? And we didn't see much difference in terms of on hand and off hand. So it would also be interesting to see in future implementations how they actually differ. So in conclusion, we conducted two studies to gather insight into how we would display information and interact with it, and we generate a set of layouts and gesture and consensus gestures. And in the future, we would like to implement this and see how participants react to that. And also, we'd like to see how this would play into the larger mixed reality applications, like how if we are interacting with real world environments or 3D elements, how would such an interface interplay with those elements. So with that, I'd conclude my presentations and open the floor for questions. Thank you very much.
Thank you so much. Is there any question? Anybody? Oh, thank you, Bradley. So Shariff, does higher agreement rate actually means legacy bias in your research?
So that's a good question, right? So there were legacy bias for, like I said, people were bringing in what they saw on smartphones into this interface. And there's also the question is legacy bias a good or bad thing?
Mm-hmm.
I guess, which is I guess still an open question.
Yeah.
So when we are looking at a newer technology, we want people to expand its make use of its full potential, I guess. But at the same time, is it going to be convenient? Are people going to find it comfortable to use new set approaches? And I believe the entire elicitation studies kind of built around that idea.
Trying to avoid legacy bias usually, right? But then that also meant that people those agreed gestures are more intuitive to those participants, at least.
Yeah.
Yes.
Yeah.
Thank you. Oh.
Yeah, thank you for the question, ma'am.
Thank you, Bradley. Another question here. Well, yeah, do you target any particular demographic with this technology?
Right now, we are thinking of it in general terms. So we're still exploring, and it's so at this stage, we are not targeting any specific demographic, I guess.
No, not yet.
Yeah.
And a question from me. So how did you come up with this idea? Do you play a lot of like video games and like watch a lot of movies?
Well, okay, that's a good question. And how much time do I have?
20 seconds.
Yeah. Okay. So like the idea is like, so we already have like smartphones, right? So the problem with smartphones, like what Khalid discussed in his previous presentation, people are like gravitating towards addiction. So the idea is like, can we expand this to a, so how do I put it? So there is an idea of wealth for like human perception, right, or biological beings. So so if we think of digital devices also having an wealth, the thing is like smartphones have a limited perception, I guess. Like which is the, so it doesn't understand our reality, our larger reality, right? So like so to interact with the mobile phone, we have to actually step into its reality, I guess. So like with mixed reality, it actually can see what we are seeing. It can like understand what we are seeing better than a smartphone. So like can we leverage that to alleviate the limitations that we see with smartphone? That's kind of where this kind of starts from, I guess. That makes sense?
Yeah, I mean, it's very interesting because like as a psychologist, I always wonder like how computer scientists come up with new ideas of technologies, right? Oh, more questions. Okay, convenience predicts the use. You say, but how do you cover all the possibilities?
It's actually a good question. Yeah, like we'll have to like so this is just based on like an initial exploration. In the future, so we'll have to actually implement this and dive into this further in future studies. Yeah, unfortunately, that's the best answer I have for now.
Okay. Well, thank you so much. Is there anything else that you want to ask? Anybody? Okay, well, thank you so much for the great presentation, Shariff.
Thank you very much.